right, well, it's 1:30. I'm gonna get started. The recorder is on, so I just checked and make sure everything is good. Um, just a quick reminder that your recursion one homework assignment is due in 2 days. So it's due on Thursday, the 31st of October. So just want to remind you, it's coming up. And I'm hoping that you guys are at least doing it and not waiting until the last moment to get started. Because if you have any questions, you might want to bring it up and ask those questions. So, are there any questions about the homework assignment that's due on the 31st? Okay, no questions. All right, so if there are no questions, we're going to get started with parameters today. We got through local variables on last Thursday, so what we'll do today is to kind of continue on and talk about parameters. Just to click on this stuff here so that we know which module we are on in Canvas. And right now at this point we are pretty much done through section 2.3. So are there any questions up to section 2.3? No questions. I'm gonna go close the door because outside is a little noisy. Oh. Those roller backpacks, depending on what type of wheel is on it, some of those can be quite noisy. All right. So what we'll do is we are moving on to parameters. I'm going to turn the volume down just a little bit. There we go. So what we'll do is we're going to start with parameters. And I'll just click on it so that we can see what it looks like. There are two types of parameters. And parameters also exist for a particular reason. A parameter is a method to pass data into a subroutine. So that's the main purpose of a parameter. What is the purpose of a local variable? We kind of went through a counter example, right, on last Thursday. So we have one, yeah, go ahead.
To introduce a new variable specific to that subroutine?
Exactly. So we want to introduce variables that are specific to a subroutine so that no other subroutine can mess around with that variable. And, different subroutines that can have local variables that are named exactly the same. That's not a problem, because variables can only be local variables are only visible from within the subroutine. So now you can name a variable I in multiple subroutines, and each subroutine can only access its own local variable I. So is that okay? Is that part okay so far? Kind of? Okay. So parameters are different because parameters do not start with an unknown value. Local variables always start with an unknown value. But parameters, on the other hand, has an initial value that is specified by whatever is invoking the subroutine. So what we'll do is we're going to take a quick look at a quick example. Okay. So we go to Office, we go to LibreOffice Calc, and it opens it somewhere else. Where did it open it? There we go. So we'll discard. Are you sure? Yes. Okay, there we go. And we have to move it to workspace 1. Okay, there we go. And then move it into the right space and then resize it. There we go. Yep, there you go. All right, so what we'll do is we're going to introduce our subroutine that define sub 1, and we'll say by val. This is how we define parameters in pseudocode. So in C syntax it's quite different, but in this class, we make it kind of more obvious, and we say by val because there are two different types of parameters. One type is called by value, the other type is by reference. So we have to differentiate between the two. So we'll say by val x, and we'll say by val y, and then we'll compute z is x plus y, and define sub. Okay. So let me fix the indentations first. Right there. Okay. So outside of the subroutine, we'll have a single invoke statement. So we say invoke sub1. Now this is the part where the invoking statement is going to well, I shouldn't say initialize, but specify the beginning value of the parameters. So in this case, I want x to start with a value of 2. So I say 2, and then I use the right arrow to say 2 goes to x. And if I want y to start with a value of 4, then I say 4 goes to y. So this syntax is definitely specific to only this class. So when you move on to C and C++, the syntax will be quite different. They will not spell out which parameter, the name of the parameter that is getting a particular value. In a C and C++ class, 2 on line 6 is known as the argument, x is known as the parameter. So when you invoke a subroutine, what you need to do is you need to specify an argument for every parameter there is specified in the definition of the subroutine. So are we good so far? Can we differentiate which part is an argument and which part is a parameter? Yes?
Why is x the argument?
X is called the parameter. X, y are parameters, and then 2, 4 as values are arguments. Or did I spell it out backwards?
Okay.
Did I? I cannot remember. Of course, it's getting recorded, so I can actually check. But let me say that one more time. Okay, this time I'll make sure it is correct. On line 6, 2 and 4 are known as arguments. So when you're actually invoking and specifying the value, those values are known as arguments. X and Y, which are the names of the parameters inside the subroutine, they are known as, well, I just said it, parameters. So are we okay? I mean, the distinction sometimes is kind of vague, and to some professors, there is no distinction. Okay, so they would kind of interchangeably use the terms arguments versus parameters. But parameters are seen from the perspective of the subroutine definition, and then arguments are seen from the perspective of the invoking statement. So that's kind of the main difference between those terms. All right, so analyzing these 6 lines of code, what is Z? Z does not appear as an argument, as a parameter, because there's no by val, Z. There's no local Z either, which means Z is also not a local variable. So what is that going to be? It's a global variable, exactly. So right now we do not have a mechanism to pass the result of a calculation from a subroutine back out to the outside of the subroutine. So the only way we can do it, that's my cell phone thinking that I'm talking to it, but I'm not talking to you. The nice thing about the 1+6T is there's actually a hardware switch, so you can actually turn off everything. So it's not software. Well, it is software interpreting the hardware, but it's a physical switch. You can just slide it all the way, and everything is now off. So I do apologize for that. So getting back to here, there's no way for a subroutine to pass a result back to outside of a subroutine. So that's why we still need the global variable Z in this case. So we'll go ahead and trace this. And let's see, we go to window, new window, and somehow it thinks it needs to open it in a relatively large size. So I'm going to have to fix all of this so it fits within on the projector. There we go. All right, so this is our trace. There are no conditions to evaluate, so I don't need the comment column, we do need line number, and we do have a global variable. The only global variable in this case is z. So with all global variables must have their columns allocated before the program starts to execute. So this is one big difference between local and global variables. With local variables, they do not even exist until the subroutine containing the definition is invoked. And they disappear as soon as the subroutine is done. But with global variables, they start existing before we run the code, and they do not disappear, when we're at the end of the execution. So they stays present all the entire time. So this is kind of important to remember. So z is a global variable, so we have to allocate the space for z as soon as, before we even start the execution of the algorithm. So the precondition is, well, we did not say anything about the assumption of z, so it starts with an unknown value. Then we get started on line 6, which is the only line that is outside of the definition of a subroutine. So I'm not going to spell out the usual stuff now. Allocating a column and then remembering the post is the return line number. So this part is something that we have done quite a few times already in the past few classes. But now the new thing is, what about the parameters? Well, as it turns out, parameters are very much like local variables. They get allocated on a per invocation basis. So just like local variables, now we say, oh, there's a parameter x, there's also a parameter y. Okay? So we allocate columns for each one of those parameters. But unlike local variables, which start with unknown values, if x and y were local variables, this would have been correct. But the main difference between a local variable versus a by-value parameter is a parameter starts with a value that is specified by the invoke statement. So in this case, on line 6, it is quite clear that we want x to start with a value of 2, and we want y to start with a value of 4. So that's why we do not have the question marks, and instead we actually have the values specified by the invoke statement. Is that okay? Do we have any questions about this particular step? Because this is how we differentiate a by-value parameter from a local variable. Now, once we have gone past this point and get into the subroutine itself on line 4, the way we look at local variables and the way we look at by-value parameters is exactly the same. We treat them almost as if they are exactly the same thing. Okay? So when we refer to x and y on line 4, we are doing exactly the same thing as what we would do otherwise, which is we look for the rightmost columns that are still in use with those names labeled in the columns. So we retrieve x from column D, we retrieve y from column E. 2 plus 4 is 6. We store the 6 back to Z, which is in column B. So 6 goes here. And then we go to line 5. Line 5 is going to do the typical thing that we do at the end of a subroutine, which means everything that is allocated for this invocation are now deallocated. So that would include the return line number and all the local variables, right? Well, we don't have local variables, but we have parameters. Parameters behave exactly the same way. Okay, they disappear when the invocation is done. So at this point, we have 3 columns to deallocate. But before we do that, we have to say, okay, let's remember this post so that we remember where to continue execution. And then after that, we take all 3 columns and then we mark it the same way as we did before. We just use a strike through to indicate that those columns are no longer in use. So if I have anything else that need to use additional columns, I can recycle column C, D, and E in this case. Yes?
Would you not transfer the numbers and cross them out as well? Like 2 and 4?
2 and 4 do not get transferred because they are useless at this point. The only reason why I transfer the post is because it is a return line number, and that tells me where to go to continue execution when I hit the end of a subroutine definition. but the value of x and y are basically just additional information, so I can do what the subroutine sub1 is supposed to do. Okay? Are there any questions about this particular example, which is kind of as simple as it gets when it comes to by value parameters? Do we have any questions about this? Yep. Mm-hmm.
The value of post and the value of x, y come the same line always?
The value of x and the value of y?
Yeah, in post. It is post and
So in post, there's no, so by the time we get to row 7 of the trace, x and y are now gone. Those columns are no longer in use, which means we don't really have x and y anymore. Because we have ended the execution of the subroutine. That invocation is now done. Is that okay? All right, cool. All right. So, I'm just thinking about the order or the sequencing of, thinking about how to do these things. So let's think about exchanging the values of two parameters. Okay, so we'll go ahead and work with that. So this is a different program. We'll define exchange as the name of a subroutine. We'll say we'll have x as a parameter, we'll have y as a different parameter, and then we have a local variable, I'll call it I, as a local variable. So there are 3 assignment statements in the typical exchange logic. Yes, I can. Yes, we certainly can. Turn on the AC. It was a little bit too cold this morning, and now it's too hot. There we go. I'm setting it to 73 degrees. I think that should be okay for most people. Okay. Okay, so getting back to this code here. So what we'll do is we say I gets the value of x, x gets the value of y, y gets the value of I, and define sub. So this is a fairly well-known sequence of assignment statements in order to exchange the values of x and y using I as what we call a temporary variable. So, and then we'll go ahead and have 2 global variables. So we'll have global variable, let's say a, starting with the value of 6, and we have global variable b to start with the value of 10. And then we're going to invoke the exchange subroutine using the value of a to specify parameter x, and then we'll use b to specify the parameter y. And then we'll go ahead and see what happens when we execute this code. Okay. Yep.
Exchange is just the name of the subroutine, right?
Yes. I forgot to say define sub exchange. But this is the kind of the nice thing about pseudocode is if you miss something and from the context it is still clear what we are doing, it's okay. Now if you're writing this as a program, that is going to be compiled or parsed by a computer, the simplest thing is going to cause the program not to work. So that's also partially why I choose to use pseudocode in this class, so that we don't have to worry about the strict syntax requirement of an actual programming language. All right, so we'll go ahead and trace this code now. We switch to the other window, add a new tab, and this time, once again, we only have line number. And this time we have 2 global variables because a and b are global variables because they are referred to outside of the definition of a subroutine. And as such, they don't really have an option. They cannot possibly be local variable nor parameters. All right, so the precondition is a starts with unknown, b starts with unknown. The first line we execute is on line 9. And on that line, a gets a value of 6. On line 10, b gets a value of 10. Okay, so far these are very simple stuff. From the beginning of this class, or from the beginning of the discussion of subroutine, we should know this stuff already. On line 11, which is invoking the exchange subroutine. Now I need to move this a little bit to the right hand side so we can see the entire thing like that. So we typically would do the same thing. Okay, we have return line number, which is post in this case, because there are no additional lines to execute after this invocation. And then just as what we talked about earlier, we know that A and B are parameters. Excuse me, X and Y are parameters. So they need additional columns for this particular invocation. And we also know, unlike local variables, which always start with unknown values, X and Y would start with specific values. So now the question is, what should I write here in this particular cell and the one next to it? Should I write down AB, or should I go to global variables A and B and retrieve the values of A and B? Retrieve the values, okay? Because A and B are simply expressions. This one can be A plus something, okay? The other one can be B times something. So we are looking at the value of the expression. It's just that A is a very simple expression, and so is B being a very simple expression. Okay, so A has a value of 6, and it is being passed to parameter X. Y has a value of 10, and it is passed to parameter Y. So this is how we set up columns D, E, and F in this case. So now we move into the subroutine. The subroutine starts on line 5 because the first 3 lines are simply telling us that we have 2 parameters and 1 local variable. Yes? Oh, wait. You first and then you.
Okay, so are we supposed to make a column for I?
Oh, you're right. I forgot about that. Thank you. I forgot about I as a local variable. So that one starts with an unknown value. There we go. Thank you. I totally forgot about I. Okay, yep. Oh, good job. All right, so on line 5, I gets the value of X. X has a value of 6, so I is now 6 as well. On line 6, X is getting the value of Y. X is right here, and it's getting the value of Y, so X is now 10. And then on line 7, Y is getting the value of I, so Y is getting the value of 6, and we're done. So if you look at X and Y, which is column E and F, their values got exchanged. So the exchange subroutine got the job done as far as the parameters are concerned. Is that okay? So then what do? We are hitting the end of the subroutine on line 8. So this time we have 4 things to deallocate because we have the return line number, the 2 arguments, and then the local variables. Those are all allocated on a per invocation basis, and at the end of the execution of a subroutine, they're all getting deallocated. So this time we got 4 columns to deallocate on line 8, but we also have to remember the return line number, just so that we know where to continue execution. So all of this is now going to be marked as unused. And then we continue execution at post, and we're all done. Except it is as if we didn't do a single thing. Okay? If you compare the state of the program prior to the execution or the invocation of exchange, and when you look at the result at post, A still has a value of 6, B still has a value of 10, so we didn't do a single thing that is useful. Yep.
So then what was the purpose of it?
Sorry?
Then, like, why use it?
To illustrate the limitations of a by-value parameter. Because a by-value parameter is an inbox, okay? Now, you would say, well, if it's an inbox, you can still kind of do a lot of things with whatever paperwork is in an inbox. Well, so it's not exactly an inbox. X and Y, as by-value parameters, they're more like copiers, okay? So instead of an inbox for X and 1 inbox for Y, you have 2 copiers labeled X and Y. So if I'm from the outside, I'm the invocation, okay, from the outside, instead of giving the paper, the actual paper with the values of 6 and 10 to the subroutine and say, go ahead and exchange these 2, I am actually making a photocopy of the 6 and making a photocopy of the Y, okay? And then the subroutine on the other side of the copier is grabbing the output from the copier and go like, okay, you want me to exchange the content of these two pieces of paper with a little post-it thing that only I have access to, that would be local variable I, and it would go in and do its job, right? So at the end, these two pieces of paper would have their values exchanged. But then what do I do?
Shred them.
Exactly. I put everything into the recycle bin and say, I'm done. Then from the outside perspective, it's like, hey, what about the values in A and the value of Y, the value of A and the value of B? They never got touched because A and B were both placed on the copier, and the subroutine was only working with a copy of what of A and B. Is that okay? Is that analogy working? So it's a very strange kind of office, right? Okay, so what if the original intent is to exchange the values of A and B instead? Okay, so some smart person is going to say, instead of using X, Y as parameters, why don't we just use A, B inside the subroutine? But then the subroutine will only be able to exchange global variables A and B. It would not be able to exchange the values of anything else, which kind of is not very useful, okay? Because I want to define a subroutine that you can give me any two things and I'll exchange the values of those two things, okay? So the purpose of this particular example is to illustrate the limitation of by-value parameters, okay? What you cannot do with by-value parameters. So are we understanding why this by-value parameter, even though it's useful, it has limitations? Yes?
Is there any other type of parameters other than by value?
By reference. So that's where we're going, okay? So now I make a copy of this program, okay? Control C, open a new sheet, and we'll modify this program just a little bit. So instead of saying by val, now I say by ref. Same thing with Y. Instead of by val, it is now by ref. Okay? By ref means by reference. And then instead of using a single right arrow, I now use a double-sided arrow. Same thing with B. Okay, now this is really just for notation purposes. In other words, in a real programming language, you do not use any arrow whatsoever. Okay, so this is only for notational purposes so that in this class, it is made very visually clear that these parameters are passed by reference. Yes?
So what do you use instead of arrow?
You don't use any symbol. All modern programming languages, they associate arguments with their corresponding parameters only by position. So if you define parameters in this order, x first and then y, then you only specify a and b. It is implicit that the first argument goes to the first parameter and then the second argument goes to the second parameter. So you don't get to see what the name is in the subroutine. But in this class, I make it very clear so that we can tell what we are doing with each parameter. So this class is definitely making the notation a lot more verbose than it really is in an actual programming language. Is that okay? Okay, so that's a good question. So minor changes when it comes to the quote-unquote syntax of the program, but what we want to do is to find out, well, does it change the behavior of the program? And if so, how? So now, once again, we got line number. We still have the two global variables A and B. The precondition is we don't know anything about A or B. And then on line 9, we still put a 6 into A. And then on line 10, we still put a 10 into B. So this part has not changed at all. But then what comes after this is very different. On line 11, okay, we have return line number. We still have one column for parameter x, we still have one column for parameter y, and we still have one column for local variable I. So that part has not changed. I being a local variable still starts with an unknown value. That part has not changed either. So now the question is, what do we put here in x and y? There are many different ways to refer to it, and I keep kind of changing the way I look at things. So at this point, I would say x is an alias. Okay, So we want to look at x as an alias. And can anyone guess? Okay, x is an alias of what? It's an alias of A, which lives in which column?
Column E.
Column B. Okay, so very good. So I would say x is also known as column B. That is the way I specify x. And if this is how I specify x, what do you think I would use to specify y?
Column C.
Column C. Okay? X is a reference, so is y. Now, the concept of a reference is a little bit foreign, okay? Let me fill in return line number first, and then we'll go back to talk about what a reference really is. So return line number is post because we don't have anything after line 11. So the return line number has not changed. So now the question is, what exactly is a reference? Because x is a parameter that is passed by reference. That makes x a reference. So is y. Y is also a reference. In the past, when I try to explain what a reference is, I would use an example when you go to the library. When you have a little piece of paper that writes down the call number of a particular book in the library, that is a reference. And then people, more and more people do not understand what that is because we don't check out books anymore. What was the last time you go to the library to look up a book and you have to go up to the correct shelf to find a book by its call number? Did anyone do that ever? Okay, we got some people saying yes, and we have a lot of people saying no. Okay, because we are living in a digital age. So instead of using that as an example, let's switch and use something else that you are very familiar with. A browser. So when was the last time you used a web browser? 2 seconds ago for some of you, right? Because I'm looking into eBay and went right? Okay, so we know what a browser is, a web browser. So in the case of a web browser, a reference is a URL. Okay, does everybody know what a URL or URI is? That's the stuff that you type in the address bar of a browser. In other words, if I switch to a browser, okay, this is the URL. It is also what you put into a bookmark. Is that okay? Versus the content that it specifies. This is the content at that particular URL. So are we okay? Can we differentiate a URL versus the content at the URL? We good? Yes? Okay. What is the quickest way, or what is the main differentiation between the two? Yeah, go ahead.
The URL is the reference for the content?
And the URL is usually a lot shorter compared to the document that it refers to. Now, not all the time, okay? You can refer to an empty HTML document, but most of the time, the document referred to by URL is a lot longer and bigger compared to the URL itself. Is that okay? All right. So using that as an analogy, let's go back to our trace and see if we can use those terms, but in the context of this program. So what you can see, or the way you can look at this is A and B, column B, I shouldn't say B, A and B, but column B and column C would be the content of a web page. Okay, now I understand, but it's only 6 and 10. Yes, I understand that it's really small or short compared to most HTML documents, but look at it that way. Okay, column B is a full HTML document. Column C is also a full HTML document. Then what would that make X and Y? X and Y are the URLs to those HTML documents. Okay, are we doing okay so far with that idea? It is a way to find the item. Okay, all right. So let's move on, because the moment we see how we make use of X and Y, I think things will get clear up a little bit. So on line 5, we ask, okay, find out what X is. and then whatever value x is, copy that into I. So the question is, what should I put here? This is for line 5. Okay, I'll give you a few choices. Okay, the first one is just do this. Okay, would that make any sense to you? No, x is supposed to be some kind of a value. Okay, I is supposed to be some kind of value. X is really the name of a parameter. I don't want the name of the parameter. Okay, so that doesn't work. What about this? Would that be, does that make sense? It is a reference. I want the value. I don't want the reference. I want what it is referring to. So what I actually end up putting here is I look at x because that's the name that I'm referring to. I look up its definition. Now I know what it's referring to. I go to that column and then I retrieve the value of that column. That is what we actually put into I, which is column G. Okay, so let me pause here and see if I can answer any questions, because this part here has a lot of concepts that might require clarification. Are we good? So when you refer to a parameter that is passed by reference, you follow the reference to what column it is referring to. And then you retrieve the value of the column that a pass by reference parameter is referring to. Are we good so far? Okay. So you might want to jot down in your notes. Okay. Today's date is the 29th of October, and the current time is about 2:05. Okay. Because that's how you can get back to the video quickly and locate the content that talks about passing by reference. Passing by value is pretty easy to understand. Passing by reference, a little bit harder. Okay? So are we okay at this point? Yep, go ahead.
If there will be several numbers like 6, 7, or maybe other numbers, then we add them, or how do you apply that?
I'm not quite sure.
In column B.
In column B,
We have 6 number. The value is 6 now.
Right.
If there will be another number, then
So you mean different values along this column?
yeah.
Okay, so that question means that we want to differentiate what is a row in a trace, right? Okay, a row in a trace is a slice of time. So if you look at a single row, that is telling you the state of the entire program at that particular specific moment. Is that okay? But time goes forward only. So that means, if you have multiple items along column B, it is the most recent value that we need to look up, because time goes in this direction. So when you look at columns, a column is kind of like a movie. It's like a reel of film, okay, of the history of one particular value. Okay, it can be a variable, can be something else, but it will let you do a playback of how the value of something change over time. But when you look at a row, it is a global picture of what each thing is at a particular moment in time. Is that okay? All right. All right, so we are now done with line 5. We move on to line 6. Line 6 says, get whatever y is and then store that to x. Okay, so we look up y. Y is an alias of column C, and that means we have to look up column C. Column C has a value of 10 at this point. So that means the right-hand side of line 6 evaluates to 10. Are we okay with that? Okay. What do we store it to? We're going to store it to x. So should we do something like this? The answer is no, because when it is passed by reference, you have to store to the column that the reference is referring to. So this x here is referring to column B, so column B is the one that is updated to, right here. So column B is the one that is updated to 10. Are we okay with this concept? So as a general rule, when you have a column that is representing a parameter that is passed by reference, that column should not change, because we only change what the parameter is referring to. We do not change the reference itself. Yep.
You stored 10 on line 5.
I store 10 on line x gets y. X refers to column B, and column B is storing 10.
Yeah, but it's line, do we do line 6?
Oh, it's line 6. Okay, wrong line. Thank you. So this one, oh, I see. Okay, so I need to cut this, put it here, change this to line 6, and that's line 5 right there. Okay, thank you. I was merging two lines into one. So do we have any questions about these two steps? Because the trace of line 5 and the trace of line 6 is really important. One illustrates what do we do when we are trying to refer to, a column, but we are only trying to use the value. The other one is trying to tell us what do we do when we're trying to update a parameter that is passed by reference. Yes?
Yeah, why would we say column B instead of just using the variable A and the variable B?
So variable A and variable B are actually quote-unquote aliases too. It's just a way for the main program to refer to those columns. So okay, so this is a good question. A, B are names of the variables, which is easy for us to remember, because we can name variables like amount owned, okay, amount owed, balance, and so on and so forth. So we can name variables so that we know what that variable is storing. The columns are referring to memory locations. So memory location 26992, what is that? I cannot remember, right? If I only have one variable, maybe I can remember that. But when they have like 16 variables, I cannot remember what each location of memory is, what is the meaning of that particular location. So the columns are referring to memory locations, and then the names, or these labels, those are the names that you utilize in a program. But behind the back of a program, the computer only refers to columns. Because to a computer, by the time the program executes, it would have no knowledge whatsoever of the names of the variables. It only knows about the columns. Okay. All right, so do we have any questions about these two lines, lines 5 and 6 of this particular program? Yes?
So in the program itself, what you're saying is it's updating the columns. It's actually taking the value that's in the local variable and passing it to the global one?
Not exactly. So the way it works, so let me just rerun line 6, okay? So on line 6, the first thing we do is we try to evaluate the right-hand side of an assignment. The right-hand side, it refers to y. So naturally, the first thing we do is to look up the rightmost column that is in use and it has a label of y, right? Okay, so we look it up and go like, okay, column F is the column that is labeled y, it is the rightmost, and it is still in use. Okay, so it's all good. Then we look up what exactly is y. Oh, it is not a value, it is a reference. So the moment we recognize it is a reference, then we say, okay, we'll follow the reference. Okay, we'll follow the reference to see what it is referring to. Oh, it's referring to column C. So we go to column C, and then we say, what is the value of column C? It has a value of 10. So that's how we resolve the right-hand side of line 6 to be 10. Are we doing okay so far with that? Okay.
So are these columns still within the subroutine? Are these columns that are being updated still within the subroutine?
The subroutine does not own the columns. It's the invocation of a subroutine that has those columns. So the difference is, let me think about an example, of, an instance, of an invocation versus the definition, because the definition is static. It really is just a description of something. But when you are invoking I know exactly what to do. Okay. You can look at the definition of a subroutine as the specification of a car. Okay. So I might be drooling over, the specification of the new MX-5 with a fast top. Okay, so I'll be drooling over it. But I'm reading a magazine. I'm reading a brochure from Mazda. Okay, so is that gonna go get me from point A to point B? No. So that is the definition. So what would be an invocation in that case? It would be me renting an actual MX-5. Okay, so I rent an MX-5. So now we have an actual car in the form of column D to column G. Okay, so now instead of a specification of what the engine can do or what the transmission can do and so on and so forth, I'm actually in a car with that engine and that transmission. That allows me to do something, right? So I would follow the instruction, do something, but at the end of the rental agreement, I will return the car so that I would not have the car anymore. Is that kind of doing okay? Yeah. All right. Okay, so getting back to this example, on line 6, we're done with the right-hand side, but with an assignment operation, we also want to look at the left-hand side and ask, where are we storing the value, right? So what do we see? We see X. Then we have to look up what X is. So we look up the rightmost column that has a label of X, and that column is still in use. In this case, that would be column E. We look up column E and we say, what is in column E? Oh, it's a reference. It's a reference to column B. That means we're not changing column E because we're not changing the reference. We are changing the column that it refers to. In this case, it is column B. And as a result, column B is getting updated. Is that okay? Sort of? Yep. Okay, very good. So for the most part, you can look at column E and F as bookmarks in the browser. They're simply storing a short URL to tell you where the actual document is. And that's it. Is that okay? Okay, I think I have one better analogy. Okay, I just thought of this. Column A and column B are Google documents. Okay? Column E and column F are URLs to the Google document. What line 6 is saying is select all from whatever document that Y is referring to and copy that to the document that X is referring to. So the question is, are you going to destroy the URL or are you going to overwrite the Google document that the URL is referring to? Is that okay? Is that working? Yeah, so. Okay, so are we good? You might want to write it down. If you find the analogy useful, you might want to write it down. And I'll try to write down something here so that just so that in the process of watching the video, you would know, you will get that. So I'm going to insert, I think there's an insert comment. Yep, there we go. So this is URL to a Google document. And so is this one. So Control Alt C. Yep, there we go. This is a URL to another document. And then over here, we'll say Control Alt C. We'll say we copy what URL Y refers to. Okay, copy the content of the Google Doc that Y refers to overwrite the Google Doc that X refers to. Is that okay? So I think with this, it should be clear, yes? Okay. All right. So the thing is, you have to hover over something in order for that to be visible. And I can certainly save this file so that I can upload it later on if anyone is interested. Okay, so we get to line 7. Okay, what is line 7 doing? We have local variable I, which is an actual document on my hard drive because I made a copy earlier, and I'm copying that to whatever Y is referring to. Y is still a reference to a Google document. It is sitting somewhere in the cloud. So I'm going to copy this value 6, which is on my hard drive, to the Google document that is on the cloud, which is over here. Do we have any questions about what line 7 is doing? Nope. We good? Okay. And that ends everything. So we get to line 8. The interesting part about line 8 is it's doing exactly the same thing as the previous program. In other words, everything that we allocate for this particular invocation of sub1 will be deallocated, all 4 columns. Okay? And some people might think, oh my gosh, you're going to delete or remove the 2 Google documents in the cloud. That is not the case. Okay? Because I'm going to take these 4 and say, yep, they are no longer useful, but before I destroy this one, I might want to make a note so I know where to continue execution. But nonetheless, I am also rendering these 4 columns unused at this point. They are deallocated. So now the question is, but isn't that bad? Because aren't you destroying the Google documents? No, I'm destroying the URL to the Google document. The Google documents are still there in column B and column C. Is that okay? Does everybody kind of understand the analogy? All I'm doing is I'm destroying the reference to the documents. Yes, go ahead.
So if you're destroying the URL, what are you going to use to get to the document?
Well, the caller, the main program, has its own bookmarks called A and B to refer to those 2 Google documents. The subroutine, has a temporary bookmark to those 2 documents. But I don't need that anymore because what I need to do, which is exchanging the content of the 2 documents, is already done. So it's equivalent to just going to your browser and delete 2 bookmarks. Well, deleting the bookmark does not delete the document that the bookmarks refer to. So that is the whole point of this whole process. But as a result, the difference between the execution of this program versus the one that does not make use of by-ref parameters is this time we actually did exchange A and B. We did not exchange the parameters. We exchanged what the parameters are referring to. Is that okay? Are we good? Are there any questions about this particular trace? If you guys need a little bit more time to think of a question, I can give you guys more time, but I want to know, do we need more time? You good? All right, so I'm gonna assume we're good with this, okay? All right, so it looks like we got everything now. We have a way to pass information into a subroutine. It's called passing by value, or in our notation it's called by val. We have a way to pass the result of something back out, okay, by using a by ref parameter. But this way of doing things is very clumsy because in order to, let's say, perform addition, okay, in order to implement a subroutine called sum, it would need 3 parameters. X, Y, being the numbers to be added, can be passed by value. And then you will need Z, which is a 3rd parameter that is passed by reference in order to get the result back out so that you can change some variable to reflect the result of the calculation. That is very cumbersome. Okay? So what we want to be able to do is to say, we don't want to do something like that. We want to be able to utilize the result of the invocation of one subroutine immediately. Okay? We want to be able to do something like that. So to do that, okay, I want to go back to the notes first because I do want to show you where we are at this point. So we are done with by value parameters. We are also done with by reference parameters. So we are basically done with this particular module, which is module 0073. Where we are heading right now, okay, not there yet, but we are heading, in that direction, is we are moving on to return values, which is this particular module. Is that okay? Does everybody understand where to find the modules to read after today's lecture? So, okay. So we are moving on to return values or returning values at this point. All right, so we'll use a very simple example to begin with, and then we'll move on to something that's more complex. Okay, so just like before, we'll start with the definition of a subroutine. At this time, we do have a very interesting name to call this subroutine. We'll call it 12. Okay, and it does only one thing, which is to return the actual numerical value of 12 and define sub. Okay. I might want to change this because all of you know what 12 is. So I'm going to change it to the Chinese name for that particular value. So that this way, we are thinking about it in a slightly different way. Okay, so I don't know exactly how to spell it out or Romanize it, so I'm going to have to look it up. Mandarin for 12. Okay, there we go. I speak Cantonese, not Mandarin, so I have to look this up. Okay, so we'll paste that here. Okay, it's 12, okay? 12, okay, 12. Okay, there we go. All right, so that makes it slightly more interesting because it is not 12. Because if I just use 12, you guys go like, okay, what is the difference between 12 spelled out versus 12 as 1, 2? Okay, so this makes it a little bit more interesting. And outside of the subroutine, we have one single statement that says x equals 2, or x gets invoke sub or invoke 12. Okay, so we'll change this from uppercase back to lowercase. There we go. All right, so this is the entire program. And the way I visualize returning a value is kind of unique to this class, so you got to be paying attention because you won't find this explanation anywhere else. All right, so we'll trace this code now. Line number, okay. We have global variable x starting with an unknown value. This is our precondition. So pretty typical stuff, nothing really surprising here. On line 4, now we have a interesting question. Is what do we do when we have an invocation that is on the right-hand side of an assignment operation? Okay. So let me just do one extra thing, which is just adding a unnecessary pair of parentheses, but it will kind of help you understand what operation needs to be done first. Okay, so we are on line 4. The question is, what do I do? Should I change x? Yes, eventually, but not right now, because I don't know what value I should use to update x. Is that okay? Who's going to tell me what value I should use to update x? The subroutine, right? The function 12, the subroutine 12 will eventually tell me, or 12, okay? 12 is going to tell me how I should update x. So the way we deal with how do we know where to go back to is now different. We don't use a return line number anymore. Why not? Because if I use a return line number of 4, then I'll restart this whole operation all over again. Doesn't make sense. If I say post, then when I come back, I will miss the part of updating x. That does not work either. So I cannot use a return line number of 4, and I cannot use a return line number of post. What am I going to do? The answer is do not use a return line number. Okay? So instead of using a return line number, every time you have a subroutine that can return a value, what you need to do is to say return info instead. So return info or return information. Return information is a little bit strange because what it does is it replicates the line that you're dealing with. It will repeat everything that you have except for the invocation that you're dealing with. That entire invocation is now replaced by a single question mark. In other words, what this return info is saying is when the invocation of shi is done, we go back to line 4, and this is what is left of line 4 that we have to perform. Is that okay? So it's still telling us what we need to do after the end of the invocation of shi, except we go back to the same line that we came from. But the remaining operation is simpler because the invocation itself will give us a single value that we can use. Is that okay? Okay, the last sentence is the most important one. The invocation will provide a single value that we can use so that we can finish the rest of that line, of what that line specifies. Is that okay? Are there any questions? Because if there are any questions, now would be a good time to ask. No questions? So we'll go ahead and do this. As we do it, if you have any questions, then we will answer those questions. We don't have any local parameters. We don't have any local variables nor any parameters. So this way, we just continue execution on line 2. So now the question is, what does a return statement do? Okay, so this is the first time we encounter this, so it's going to be new, but at some point you're going to say, oh, this is really boring. And hopefully we'll get to that point sometime today. So what a return statement do, or what it does, is the follows. It will look up the rightmost column that is in use and labeled return info. Let me say that one more time. It will look up the rightmost column that is in use. Okay, we have heard of that again and again, but this time it has to be labeled return info, return information. Okay, fine. We found column C meets that requirement. Cool. What are we going to do then? Simple. We take the question mark and we replace the question mark with the value that we are returning. So on line 2, it's returning a numerical value of 12. So what we do is the following. We look up the column, we retrieve what is in that column, copy and paste it, and then all we do is we replace the question mark with the value specified by the return statement. That's it. Nothing else. Then what about X? We now know what we need to put into X, so why don't we update column B with 12 at this point? We do not do that. Okay? The one thing the return statement does is simply to replace the question mark with a particular value. And when that is done, we're done with the return statement. Is that okay? Yep. Say it one more time. Not yet. So at this point, okay, remember each row is representing a moment in time, right? So if you look at this particular moment in time, X as a global variable, which is column B, is still having an unknown value. But the assignment statement that we are trying to deal with on line 4 is now resolved. We know what the right-hand side is. Is that okay? But the assignment operation has not been performed yet. Is that okay? Because in order to perform the assignment operation, we have to be back on line 4 first. And we are not on line 4. Which line are we on? We're on line 2. How do we know we're on line 2? That's what the line number column is telling us. Okay? So the line number column is analogous to a timestamp. Okay? It's telling us what time it is. Okay? Sort of. But it's actually telling us which line we are supposed to be executing at this moment. All right. So when this is all done, we go to line 3. What does line 3 do? Line 3 would do something that is very similar to what we used to. It will look up the rightmost column that is in use, but it has a name of return info this time. So what is different this time is this time we copy this entire thing to the line number column, and then we deallocate it. So now we deallocate it because it's of no use to us anymore. We have just made use of the return info cell. So when we get back to line 4 does not look like this anymore because line 4 is now resolved. We know the value that is, we know what the value is involving the invocation of cis. Sure. Sure? Sure. Sure. And if you want to learn Mandarin, you will also know that each word or each syllable has 4 intonations. So you got to have that right too. But this is not Mandarin, so we are not going to pay attention to that. We'll just say it is 是. Okay? So when we get back to line 4 this time, the invocation of the subroutine has disappeared. In the place of the invocation of the subroutine is an actual value. Is that okay? So when you look at line 4 right now on row 7 in the trace, do we know what to do? Can we perform the assignment operation? I think so. So we'll go ahead and perform the actual assignment operation at this point so that column B is now having a value of 12. Is that okay? Now that line 4 is done, we get to post, which means we're all done. Are we doing okay so far with this trace? Because the way I try to use a spreadsheet to visualize what a return statement does can be a little bit difficult. But the bottom line is, what do we do when we invoke, and what do we do when we execute the return statement? Are we okay, or do we need a little bit of time? Yes?
So does the return info line work as a return line number and what's supposed to do at the same time?
I could not have used a return line number because a return line number says, go back to that line and basically start from the beginning of that line. So I cannot do that. So return info is telling me to, in this case, okay, let me highlight which part I'm talking about. So when I set up column C initially, like this part here, it is telling me that I need to go back to line 4. But it's not telling me to start from the beginning of line 4. It is telling me that when you get back to line 4, the right-hand side would now be resolved when I get back to line 4. So I can continue to perform the assignment operation when I get back to line 4, and that's exactly what we did on row 7 of the trace. Is this okay? Are there any questions about this?